In this problem, we're going to be solving a radical equation using the graphing method on our calculator. So here's the function. It turns out that it's a radical function, and our job is to solve the equation, find x, the input, for which would make the output f of x equal to 4. So this is an equation. It might not look like the way you're used to seeing it. So just to make it look a little bit more like what you're used to seeing, imagine if I took this notation f of x here for the output, and since it's equal to 4, making a substitution. So if I was to take this notation f of x and replace it with the number 4, it would look like an equation like this. So you just have to visualize me replacing all of this notation f of x with the number 4, and it would read 4 equals the rest of the equation, square root of 4 plus 2x, like this. So whether in this format or this format, you can solve the equation using your graphing calculator by typing the left-hand side into y1 and the right-hand side into y2, or vice versa. So it actually gives me a hint of what window to use on our graphing calculator. And then when we're done, we're going to follow the steps below. Follow the steps below to show the intersection graph on the computer. So we're going to graph it over here, and then by hand we're going to graph it on the computer. So turn your calculator on. To type an equation, you go to y equals. Since the left-hand side of my equation was 4, at least the way I wrote it on the left, I'm going to type 4 into the y equals. That's going to give us a horizontal line through 4. The other equation, I'm going to go down or press enter. And I need the square root, so that's right here in blue. It might be a different color on your calculator, but either way, you press the second key and then the x squared key to get a square root. It gives me a left parenthesis for free, no extra button presses. I'm going to type in 4 plus 2x, and then I'm going to cap off those parentheses to let the calculator know that both the 4 and the 2x is underneath the radical. Now I need to graph it, and usually the hardest part is finding a window, but that's done for us. There's already a suggested window in our calculator. So before graphing, I want to make sure that I'm in that window. So I'm going to click window, and it says that the x min should be -4. You don't have to delete the old one. You can just type over the old setting with the new. I'm going to down arrow to the x max, and the suggested value for that is 8. Down a couple times to y min, and the suggested value is -10. Don't need to change that. And y max is 10, and that's the suggested value, so I don't need to change that. Now that that's done, I can graph it, and I should first see that line y equals 4. Then my second equation is a radical, and I don't know if you know those usually look like, but in red they look like this. So it turns out the solution to the equation that we're finding, the x value that makes this work, is actually the x value of the point of intersection. So we need to use the intersect feature on the calculator to find that. So to do that, the intersect feature turns out is in the calc menu right here in blue. So since it's the second feature, I need to press second, then the trace key to get to the calculate menu. It's obvious that the intersect feature is right here, number 5. I'm so lazy, I don't want to scroll down and press enter. I just press 5. And then it's going to ask me a couple seemingly silly questions. It says, is this your first equation? The calculator does not know that I only provided it 2 equations. It might be thinking that I have 10, and it want to know which of the 2 of the 10 do I want to find the intersection of. So you actually have to press enter and say, yeah, y equals 4 is my first equation, enter. And then, yeah, this is the second equation. It's the second curve. Press enter. Now, the guess is sometimes important, especially if there's multiple intersections. The fact that there's only one intersection in this graph, you could just press enter. But what the calculator wants you to do is trace to the right, since I need to go to the right, to move the cursor over the intersection. The danger of having students do this now is visually it looks like we're at the intersection, so students think that that perhaps this is the answer, say. But this is still just a guess. If you want to actually run the procedure, you actually have to press enter as your guess. We're ending this as the guess. And then there could be some round-off error, but it says the word intersection now, and that's key. This says that this isn't just a guess or us tracing around randomly. This is the intersection of the 2 graphs, and oftentimes you'll see round-off error on these questions. But in this case, we get the exact answer, x equals 6. Now, if you're reading the directions, it says write the point of intersection as an ordered pair. So even though the solution of the equation is simply x equals 6, they didn't ask for us just to write the solution. They actually said write the point of intersection as an ordered pair. So I'm going to click down here, and the first field here goes with the first question. I'm going to write the point of intersection using the proper notation, which is parentheses 6 comma 4, right parentheses. So that's the point of intersection. So we've done one. It does say round the value of x to 2 decimal places, but it says as needed. Obviously 6 has infinitely many decimal places, so it doesn't make sense to round that to 2. Says part 2 is we are going to use the line tool to draw the horizontal line y equals 4. So we're sort of doing what the calculator is doing over here, but by hand. So I need to scroll down till I see the line tool, and it's currently on the curve. So I need to click on the line tool, and I need to draw a horizontal line through 4. So you can pick any point that would be on that line, doesn't matter where it's at, and then just scroll left or right until you get a horizontal line through 4, let go, and that does number 2. Number 3 says use the square root tool. That's this right here. I'm going to click on the square root tool to draw it, but be careful. It says to draw this function, first plot the point furthest to the left. And the person who made these questions made it come out nice. At this point, I don't think it's the intent to actually do algebra to find the exact value. I think we would assume that -2, 0 is the point furthest to the left on the graph. So I could prove that using algebra, but I don't think that's the intent of this this problem. So I'm going to say -2, 0 is the point furthest to the left, followed by one more point. So why not use the point we already found, 6, 4? So I've already selected the curve. I'm going to point and hold down the mouse button at -2, 0, scroll to the right, and then my second point is going to be 6, 4, and I'm going to let go. That basically does step 3. Step 4 says use the point tool. That's this guy down here, so I'm going to select it to identify the point of intersection if it exists. So it's kind of confusing because there's already a point plotted at 6, 4, and that is our point of intersection, and it certainly does exist. But this is different. It doesn't count. You actually, if you want to plot a single point rather than a whole graph, you have to use the point tool. So you really have to go through these directions carefully, make sure you're doing exactly what they say, and make sure you do all of them. So I'm using the point tool, and I'm going to plot 6, 4 by just clicking and letting go. And you notice the dot is round rather than square and a little bit bigger, and that's exactly what Math AS wants you to do.